Hey students, this is Mr. Deaver, and I'm here to teach you how to use our pH equations to figure out the pH or pOH of a specific acidic or basic solution. Now, we're going to do two example problems together, and in these example problems, we've given you some questions to help you think through the problem and get to the answer. These questions are not listed in all the problems, but you should think through these problems or think through these questions for each problem, even if you aren't writing out these questions or answers each time. So the first thing we want to think about when they give us a problem is this going to be an acid or a base? They're asking us to calculate the pH of a 0.04 molar solution of HCl. Remember, this molar here is telling us the concentration of HCl. Well, we know that acids have what in them? Acids have an H, so this is an acid. Now, this next question, which we're going to see soon why this is a relevant question, how many H's or OH's are in this compound? Now, since this is an acid, we're concerned with the H's here. Well, in one molecule of HCl, how many H's are there? Just one, right? There's no number next to that H, so that's an invisible 1. So the next question is to get either the H plus concentration or the OH minus concentration. Now, to get this, we have to remember that acids and bases are going to dissociate in water. That means they're splitting apart into smaller parts, kind of like sodium chloride does in water. So let's kind of see what that looks like in the case of HCl, or hydrochloric acid. If we have one molecule of HCl, it's going to split into two things. What are they? A positive H plus ion and a negative chloride ion, right? So for each one HCl, we get one H plus and one Cl. So if we have 0.4 molar HCl, what's the molarity or the concentration of the H plus ions going to be? Well, since it's a 1-to-1 ratio, it'll be the same molarity, right? 0.4 molar HCl, 0.4 molar H plus. Just like if you put in one molecule of HCl, you get 1 H plus. If we have 0.4 HCl, same, 0.4 H plus. And then also there's a 1-to-1 relationship between the HCl and Cl minus. So we're also going to have 0.4 molar Cl. This is why it's important to think about how many H's there are in the compound. Since there's only one H, the H plus concentration stays the same. It's 0.04 molar. Okay? Last step is to get the pH. So here is our pH equation. pH equals negative log of the H plus concentration. And since our H plus concentration is 0.04, we're going to plug in that 0.04 to the A for the H plus, and let's put that in the calculator, okay? Negative log of 0.04 gives us 1.40. I'm going to round it up to 1.4, and that's our pH. All right, let's do example 2 together. They want us to calculate the pH of 0.03 molar CaOH2, calcium hydroxide. Is this an acid or a base? Since it has OH, it's going to be a base. We know that things that have hydroxides are bases. How many H's or OH's are in the compound? Since this is a base, we care about the OH's. And because of this 2 here, we can see that every molecule of calcium hydroxide has 2 OH's. So that's going to be relevant for answering this question. What is the H plus or OH minus concentration? Again, since it's a base, we care about the OH minus concentration. And to help us, again, let's look at a little visual of how calcium hydroxide dissociates in water. What are we going to get if we have one molecule of calcium hydroxide? Well, we're going to get, obviously, a positive calcium ion, which has a +2 charge. And how many OH's are we going to get? Well, we're going to get 2 of them. So we're going to get actually 3 things, 1 calcium and 2 hydroxide ions. So if we have 0.03 molar calcium hydroxide, what's the ratio of calcium hydroxides to calcium? 1 molecule calcium hydroxide, 1 molecule of calcium ion. So it's a 0.03. The concentration of calcium ions are going to be also this 0.03 molar. It's the same. But for hydroxide, it's a 1 to 2 relationship, a 1 to 2 ratio. Every one calcium hydroxide molecule gives out 2 hydroxide ions. So we're going to multiply that by 2 to get our hydroxide concentration. It's going to be 0.06. So the OH concentration is equal to 0.03 times 2 because there's 2 hydroxides, and that gives us 0.06 molar. That's the hydroxide concentration. All right, great. Now let's get the pH. Okay, well, we can't do this in one step, right? Because to get the pH, we need the H plus concentration. We don't have that, though. We have the OH concentration. But we can use the OH concentration to get what? We can use it to get the pOH. So let's do the pOH first, okay? pOH is equal to negative log of 0.06. Let's put that in the calculator. Negative log 0.06 is 1.22. So that's our pOH. And then we can use pOH to get pH using this formula. So pH is equal to 14 minus 1.22, which is 12.78. So when you're doing these problems, make sure you pay attention to, is it asking for pH or pOH? Are they giving you an acid or a base? How many H's or H's are in that formula? And therefore, do you have to multiply by 2 or possibly even more to get the H plus or OH minus concentration? There's a lot of things to think about here. So you got to use that there brain of yours to figure it out. Alrighty then. Good luck.